So let's talk about another major application of the Pythagorean theorem, what we call its converse. So the original theorem states that if you have a right triangle, then the sum of the squares of the legs equals the square of the hypotenuse. Now, the Pythagorean theorem itself has a really cool property, which is that it works in reverse as well. That is what converse means. Converse means to swap the parts of the theorem. So instead of saying we're starting with a right triangle and then we know the sides have this property, we can say this. The converse of this theorem is that if the sum of the squares of the legs equals the square of the hypotenuse, then the figure is a right triangle. So the original theorem, if you have a right triangle, then the sum of the squares of the legs equals the square of the hypotenuse. The converse flips it around. If you have a figure where the sum of the squares of the legs equals the square of the hypotenuse, then the figure must be a right triangle. This allows us to determine if something is a right angle by only using a ruler, which is a really powerful tool to have. Let's take a look at this in action. Let's say I have a lovely triangle, not to scale, and it has lengths 6, 8, and 10. And we want to know, is it a right triangle? So if it's a right triangle, then the Pythagorean theorem would have to hold. If it's a right triangle, a squared plus b squared has to equal c squared, where a and b are the lengths of the legs and c would be the length of the hypotenuse. So I look at the sides of my triangle. The hypotenuse is always going to be the longest side. This is the longest side. Because in a triangle, if one of the angles was a right angle, then this side would have to be opposite the largest angle in the right triangle. So therefore, the side that's opposite the biggest angle has to be the biggest side. If this is a right triangle, 10 would have to be the hypotenuse, and 6 and 8 would have to be the legs. So I'm going to ask myself, well, what's 6 squared plus 8 squared? Well, 6 squared plus 8 squared is 36 plus 64. That is 100. I'm going to ask myself, what is 10 squared? Well, 10 squared is 100. So I know that 6 squared plus 8 squared equals 10 squared. For this figure, the sum of the squares of the legs would equal the square of this hypotenuse. Therefore, I can conclude that this must be a right triangle by the converse of the Pythagorean theorem. Let's try another triangle. Let's make this one 3, 7, and 12. So once again, I ask myself, first, what is the potential hypotenuse? To see, is this a right angle? 12 would have to be the hypotenuse because it's the biggest side. And in a triangle, the biggest side has to be opposite the biggest angle. So if 12 is my hypotenuse, I know that in order to be a right triangle, it'd have to satisfy the Pythagorean theorem. Does 3 squared plus 7 squared equal 12 squared? Well, 3 squared is 9. 7 squared is 49. And I'm asking myself, does this equal 144? Well, 9 plus 49 is 58. And sadly, 58 does not equal 144. Therefore, this is not a right triangle. We didn't have to use any protractors. We didn't have to measure any angles. Because this triangle does not satisfy the Pythagorean theorem, therefore we know it cannot be a right triangle. But this triangle does satisfy the Pythagorean theorem, and therefore we know it has to be a right triangle. The only triangles for which the sum of the squares of two sides equals the square of the third are right. And so if it matches the Pythagorean theorem, it has to be a right triangle. And if it doesn't match the Pythagorean theorem, it can't be a right triangle. And that is how we use the converse of the Pythagorean theorem to see if a triangle is right or not.